Jupiter is a really hostile place to operate a spacecraft.
A lot of the fear that you have going to a place like Jupiter and flying into unknown parts of its environment is that something could happen.
Things go wrong. You can't control the environment.
We're farther away from the sun than any solar power spacecraft has been before.
It's going to be traveling through the strongest magnetic field that any spacecraft, that any instrument has ever flown through in space.
It's like flying through a sea of radiation bullets. And it's been my job to be afraid.
One of the challenges that we face when we do long missions like this is we need a spacecraft that's very reliable.
The scientists may say we want to be in a certain place, but how do I make a spacecraft survive? How do I get it there? How do I get the instrument to work? And that's really where it comes to the engineers to sort of sort through these challenges.
For most of our one-year mission, we duck underneath the radiation belt.
Juno went from proposal to launch in about 5 or 6 years, and that seems like a really long time, but most of the little steps in between always feel really rushed. There's never enough time to do something that's never been done before.
You start defining out what are the challenges. Well, we had more than anybody else on any other mission probably because we had this incredible environment that we had to deal with. You can't reproduce Jupiter on the Earth, but you can try to reproduce the conditions as best you can.
We test, we'll over-test to make sure what we see in space, we can handle that.
It has these enormous solar panels because we're the furthest spacecraft from the sun, so we needed to have a very large area solar panels so that we could get enough power. But it's still amazing to me, that spacecraft operates on something like 500 watts of power, which is like maybe 5 light bulbs in your house.
Nobody's ever operated this close to Jupiter, this deep within the radiation belts. So we had to take our most valuable and critical electronics and house them in a radiation vault. And that radiation vault is 400 pounds of titanium surrounding our most critical electronics. And it's very effective.
A lot of the instruments that had to go inside Juno's radiation vault, they're packed into the vault in a very strategic way so that the more delicate ones are right in the very middle of the instruments inside the vault, and the hardier ones are outside.
It's a spinning spacecraft. That doesn't affect our day-to-day operations much, but it is a very different type of spacecraft than most of the other missions we launch and fly.
We knew we had to be a spinning spacecraft because a lot of our instruments need to look at the planet and look at the sky, look at the planet, look at the sky to see what's different.
There are a couple of times in the life of any mission where everyone holds their breath. The first, of course, is launch, because you've just put your cherished spacecraft and all those instruments on top of what is essentially a large bomb.
You're going to have shaking as you're launching, so you need to make sure everything's strong enough to survive that.
It's probably a good large portion of our design requirements have to do just with surviving launch and making sure that all the structural things work together and nothing gets shaken too hard.
All Centaur systems are operating nominally at this point in the flight.
From that point forward, you're just mentally checking boxes as the spacecraft's going through its steps.
Centaur's achieved spin rate, and we have spacecraft separation.
And, feeling good each time something happens it's supposed to, and then saying, okay, what's next?
On Juno, we know that the space environment is going to throw us a loop sometimes. And so in those situations that we know are either high priority or higher risk, we try to come up with contingency plans to have in place beforehand so that we're not caught in a situation where we're scrambling to fix something.
New things are not always our favorite things because that means that something is not working the way we wanted it to, but it doesn't always mean that that's a bad thing. This, of course, for us happened before we were going to do our final main engine burn.
When we got to Jupiter, we did a burn as we came around the planet to change from the orbit that was flying around the sun to one that was around Jupiter. We had decided that we wanted that to be a 53.5-day orbit, and we planned to do 2 times around the planet in those longer orbits. And as we came to the closest approach at Jupiter, we were planning to fire the main engine again and shrink that orbit down so we'd be coming around the planet every 14 days.
We're doing the last-minute preparations, reviewing the data to make the decision, all right, we're ready to go. We noticed one of the check flow valves open too slowly. And that would change the rate of the fuel flowing into the engine.
I remember hearing that something had happened and we were all gathered together. The first thing you do is look at all the data. Is Juno safe? Has anything been damaged? Are we safe to carry on? What do we do next?
While we may have been able to execute the maneuver to get down into a 14-day orbit, that represented a risk. And from our perspective, it was an unnecessary risk with a billion-dollar mission because we do the science that we had planned to do equally well in a 53-day orbit versus a 14-day orbit, and in some cases, we do some things even better.
Because of the change of our orbital period, the mission will go longer than originally planned because we'll be visiting close by the planet less frequently. But in the same regard, the spacecraft is very healthy technically.
We haven't seen much degradation at all from radiation or the environment, which means we designed the spacecraft to be very robust. We knew Jupiter was going to be a very challenging environment. So we're very optimistic about the spacecraft well into 2021. It's surreal. It's still almost a little unbelievable what we're accomplishing today.